Okay, this next chart shows all the possibilities of two dice rolled. So if you roll a 1, you could also roll a 1. So here's a 1 and a 1. Or you could roll a 1 and a 2, 1 and a 3, 2, 1, 2, 2, 5, 4, 5, 5, 5, 6. Okay, and there's a column for 6. So we're going to answer some questions about dice. First one says, what is the probability of rolling 2 dice and getting a sum of 4? So sum would have to add up to 4, or getting a sum greater than 10. So if it adds up to 4 or is greater than 10, well, 4 is not greater than 10. So those cannot happen at the same time. So let's look at all of the possible ways to do a 4. Well, a sum of 4 could be a 3 and a 1, a 2 and a 2, or a 1 and a 3. So those 3. So there's literally 3 different possibilities. And then there's 36 total possibilities. 6 times 6, that's 36 different rolls that you could have. So that's 3 out of 36. Plus getting greater than 10. So we need to look at this chart and look to see where they're going to be greater than 10. Well, the only ones that are greater than 10 are, if we look, 5 and 6, which add up to 11, and 6 and 6, which add up to 12. Those are greater than 10. So there's only 3 of those as well. So 3 out of 36 for that one. So that's going to be 6 out of 36, which is equal to 1/6. Let's look at the next one. Probability of rolling 2, so again, 2 dice, a sum that is even, or a sum that is greater than 9. Well, you could have a sum that is 10 and be even. So those are definitely going to happen at the same time, which will be inclusive. So let's look at all of the even possibilities first. So if we look up all the even possibilities, then if there's 36, if there are 36, I lost the page, hold on. I'm trying to get it back here. If there are 36 different possibilities on this chart, then half of them are going to be even. So that means that we have 18 out of 36. But then remember, we're going to add that to the other probability. So anything that's greater than 9, so that means 10, 11, or 12. Well, if we look, 10 is going to be right here, 11 is going to be here, and 12 is going to be here. And so if we add those up, that's 1, 2, 3, 4, 5, 6 different possibilities. So that's 6 out of 36. Well, out of all of those, which ones do we want to subtract? We want to subtract the ones that are both even and add up to 10. So the ones that are even and add up to 10, those are going to be anything in here. And of those, we have those adding up to 10, and those adding up to 12, there's 4 of them. So we have to subtract 4 out of 36. This is actually a really silly problem, and I'll explain in a second, but if you add 18 plus 6 minus 4, that's going to give you 20. Out of 36. And 20 divided by 36 reduces to 5 over 9. And the reason why this is really silly is because you can actually just add them up. You could actually say, oh, hey, what are all the even ones? So obviously it's 36. And then right away you could be like, oh, okay, well, this little corner here, I'm just going to get rid of those 4 because those are the only ones that are even. So it's kind of silly. But, you know, if you can think of it that way, you could also do it that way. All right. Let's look at this bunch here. So it says we got the diagrams to the right, and they want us to figure out the probability of A. So the probability of A, we're just going to add everything together. So 0.3 plus 0.2 is 0.5. Okay. The next one is the probability of A and B, or remember, the intersection of A and B, and that one is just 0.2. It's the stuff that's in between right here. So 0.2. This one says A or B. Remember, we're adding those together. So A union B, which is everything of A and B, of A and B together. So it's 0.3, 0.2, 0.1, which is 0.6. This one is A complement, or A prime. We haven't seen this little c before, but c just means complement, means not A. So what is not A? Well, it could be anything in just B, or the outside stuff. 0.1 plus 0.4, which, if you add those together, add up to 0.5. And then A intersect not B, well, that's just stuff that's only in the probability of A, like without B. So that's going to be 0.3. Right, because we don't want that middle part. Alright, now let's do this one. Probability of C is 0.4. Huh, that's different. Notice that C and D don't overlap. A and B did. Those are inclusive. These are disjoint. They're not even connected. They're not joint. They're connected. They're separated. So let's do this one. Probability of C and D, which is 0.9, but it wants the intersection. It wants C and D to happen together. Well, C and D can't happen together. That's like flipping a coin and rolling a die. So that means that the decimal for that one is actually going to be 0. Can't happen. But if you're talking about C or D, then you're going to add those two together. 0.4 plus 0.5 is 0.9. C complement is anything that's not 0.4. Well, if it's not 0.4, then you would have to do 1 minus 0.4, which is 0.6. And the complements of C and D, that actually does overlap. What's not C and what's not D is this 0.1 right here. So the complements of both of those intersections is 0.1. Because all this stuff out here intersects itself, technically. Alright. Now let's do some math. The probability of A is 0.5. The probability of B is 0.4. We want to determine the probability of A and B if they're mutually exclusive. So if they're mutually exclusive, then that means that we're using the second diagram. So we would put 0.5 in the first circle, 0.4 in the second circle. So the probability of them both happening together, they're not overlapping. So the probability is 0. So the probability of any mutually exclusive things happening at the same time is 0. They can't. They cannot happen. The probability of you born in July and August is 0. Can't be born in 2 months. Okay, let's look at the probability of A is 0.4, B is 0.3, A and B is 0.1, and these are definitely going to be inclusive. So we want to use this first one, and it says that them happening together is 0.1. So we want to put 0.1 in the middle, and we want to subtract this 0.1 from both of them. So the probability of A is 0.4, so if we subtract 0.1 from 0.4, that's 0.3. And then this one's going to be 0.2 if you subtract it, which actually means that the remaining, this all adds up to 0.6, so the remaining is 0.4 on the outside. So the probability of A or B together, all of them added up, this one's a little different, it says or. Then you're going to add those up, 0.3 plus 0.1 plus 0.2, that's 0.6. Okay. This one, again, is inclusive, so we're not using this one. So we have 0.5 is the probability of point A, or of probability of A. The probability of B is 0.3. The probability of A or B is 0.6. Which means that together they add up to 0.6. They want us to determine the probability of A and B, which is the intersection of the two, if they're inclusive. So, we have to think about this here. So, if A is 0.5, all of point A, or all of probability of A is 0.5. All of probability of B is 0.3. There's some math we gotta do. We have two unknowns. We know that them both added up together, these two parts added up together are going to be 0.5. We know that these two parts added up together are going to be 0.3. So we need a system of inequalities, or equations, sorry, the system of equations. So in the next video, I'm going to show how to set up the system of equations for this problem.